I welcome all of you present here. I'll be presenting on our final year project, Agroguard, which is an animal repellent for smart agriculture using Atmega 328P microcontroller. My guide is Assistant Professor Sunita S. Pillai from the Department of Electronics and Communication Engineering, St. Joseph's College of Engineering and Technology, Palai. My team members are Anaga R, B. Abhishek Chipimol Kebinu, and myself, Martin Francis. So, these are our table of content. Now for the basic introduction. So from the name itself we can understand that animal repellent. It is Agroguard is an animal repellent product which deter animals from specific area. This specific area can be our crop area, can be near our homes, which are near to forest area. As we all know, nowadays we are facing an issue with wild animals encroaching into our land area. In most parts of Kerala, this in especially in forest area, we people living there face this issue of animal encroaching to, coming into their land area. Animal coming into their land area attacking crops. Sometimes in this process, people may also lose their life. Also, there are laws related to animal that avoid us from harming any animals. As a result, we cannot harm the animals in any sort of way. So this is where we believe that our product would be playing a very great role, because our product will not be harming any lives here. We will be scaring the animal away. When our product identifies the animal, it just scares the animal away. It does not give any physical damage to the animal. And I believe that our product will play a crucial role in human wildlife interactions, protecting both human and wildlife. We can also protect our crops from these wild animals. And this product is more of a way to coexistence rather than harm to wild animals. To our objective of our project, to design and develop an AI-based animal repellent system. We have reviewed an existing papers related to animal repellent to make more advanced AI to identify animals, more advanced AI which are far more better than the pre-existing AI, to conduct customer needs and preferences for the development of an AI product, to research on different ways of implementing the system, to implement different frequency ranges to which animals are sensitive to design and implement circuit required for construction of animal repellent product. After the design has been completed, we will be designing a PCB layout, and after the PCB layout has been completed, we will be making our hardware. After that, the hardware and software are integrated together to form the final product. So these are our application, basic application to protect agriculture and gardens. So basically our project aims to protect agricultural land area, also human life, due to the attack of wild animals, to protect the wildlife. So using our product, we are also not harming any animals here. So we are also protecting wildlife without causing any, protect livestock, which there are livestock. Maybe we breed animals. There are livestock in area related, in farm area related to forest area. So we are also sometimes animals, wild animals may attack our livestock. Also, we are also protecting livestock here. Now this is our literature survey. So we have conducted literature survey using many papers, and we have primarily identified by 5 papers as our main papers, and for reference purposes. We have identified first an animal repellent system for smart farming using AI and its community. Basically, it uses identification of animals, surveying the area using AI and deterring the animal. But there are problems with this. It has power constraint issues, real-time responsiveness, and cost issues. Next, next is the design deployment of wild animal intrusion detection and repellent system using IoT. It uses Internet of Things. It uses various sensors to capture, identify the animal. and uses Internet of Things to send the data related to animal. The system is more complex and it lacks clarity because the sensors may not work properly in this case. Then machine learning based acoustic repeller. Basically, this paper uses machine learning techniques to identify an animal. After the identification of the animal has been done, it produces audio frequencies to repel the animal away. The problem with this is there is less response time and it is less effective, and problems with the sensors used for animal identification. Now next paper is surveillance of rogue and wild animals using image. This uses image processing and IoT technique to identify animals and warn people about the animals encroaching their land area, and it also provides many maintenance challenges and data security. Application and challenges of IoT bird repeller. Basically, this is for repelling birds. The sensors are used to identify which bird, and sensors are used to identify birds. And after the identification, and it produces sound ranges to repel the animal away from the agriculture land. It also faces problems like sensor accuracy is very low, and the integration complexities. Now these are our target users. We have identified many target users. Farmers as our primary target users, outdoor enthusiasts. Sometimes people going inside the forest for hiking purposes may also be attacked by animals. So our product can also, in some cases, save the lives of people going for hiking. Wildlife officers and the forest department, because they are more related to the forest, and I think they will help us in implementing this product. And now secondary usages include households, business, and government. Government will take an initiative since it is not harming any sort of animal. Now customer needs. These are our customer needs. Safety, so it should not affect any of the animals or human beings in any way, harm any of the animals or humans in any way. It should have affordable pricing, should be accurate in identify the animal, and have a real-time response. Should have long life. It should be sustainable, easy installation, and it should be portable. Now the target requirements. The system must be designed to not harm both humans and animals. The system scares away animals using different frequency ranges. System must be capable of detecting the target correctly. System must respond to the target faster. System must be able to correctly identify the target and generate audio to scare away. The system must be easy to move. Easy to move. That is, it should be portable and it should have long life. Now, with respect to the customer needs, we have created our need metrics. We have correctly identified the need matrices here. What all things should be included here and all. With respect to the need metrics, we have made our target specification. We have correctly identified the needs and matrices for our target specification, and identification of the values that can be used. Now this is our basic flow diagram. This is how our system's going to work. So we'll be using something called an IP camera. IP camera is a camera which has Wi-Fi capability inside it. The Wi-Fi IP camera will be surveying our land area and sending the video data to a web server using the Wi-Fi capabilities. The streaming will be taken screenshot of the stream will be taken from the program inside our cloud, which will be taking the images, resizing it, and give it to the AI model. AI model correctly identifies if there are any animals, and if there are any animals, the data is sent to the Atmega 328p microcontroller via the ESP01 module. And then it is Atmega 328p checks if an animal is present. If an animal is present, it 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 takes the audio related to the recognized animal and scares the animal away. If no animal is identified, then the process is repeated again and again. Now this is our use case this is use case diagram for our IP camera. So basically, the IP camera takes there is a need for a technician for maintaining the IP camera. So the animal when the animal approaches, the video is captured using the IP camera and sent to the AI animal detection model inside the cloud, which will be taking screenshots, snapshots of the video, streaming on the web server. This is our use case diagram for our system. Here also we need a technician for maintenance of a system. The AI model detects the animal by using the images taken from the web server, and it identifies the animal successfully and sends the data to the ESP01 module. Then the ESP01 module sends it to the Atmega 328P. We are using the ESP01 module here because Atmega 328P does not have its own Wi-Fi capabilities in itself. As a result, we should be using a Wi-Fi shield here. We will be taking the ESP01 as the Wi-Fi shield here, which will be communicating with the Atmega 328P with using software serial library. Basically, UART communication. We will be after the data related to the animal is received inside the Atmega 328, checks which animal has been identified. With respect to the identified animal, it takes the audio related tailored for different animals. It sends request to the SD card module to send the audio related to the tailored animal, and the SD card module sends the audio related to the tailored animal to the Atmega 320. After the audio is ready, it is sent to the palm amplifier, which is a 3 watts amplifier. After the amplification and done, we will be giving the audio signal to the 10 watt speaker, um, which will be playing the sound in such a way that it can repel the animal away. We will be using a LCD 16 cross 2 screen here to see the status of our system. Now this is our basic sequence diagram here. So basically, when an animal is approaching the land area, the IP camera is capturing the video all the time. After the video is captured, it is sent to a web server. The MATLAB cloud takes snapshot of the video and converts the video into images maybe every 20 to 30 seconds. After that, it is given to the input layers of the AI model inside the MATLAB cloud. Inside the MATLAB cloud, the AI model identifies the animal and sends the data to the Atmega 328P via the ESP01 Wi-Fi module. Inside the Atmega 328P, it identifies, checks which animal has been identified and requests data related to the identified animal from the SD card module. SD card module sends the identified voice data tailored for various animals. After it is sent to the Atmega 3, it is then sent to the amplifier module for amplification purpose. After the amplification is done, it is played in such a way that it can deter the animal away using the 10 watt speaker. Now this is our detailed block diagram. Basically there is an external IP camera which has Wi-Fi capabilities, which will be streaming its video, and the video images will be captured by the animal detection program inside the AI model in cloud. After the identification is done, ESP01 module into it, the data of the animal is sent to the ESP01 module. From the ESP01 module, the data is out of the animal is sent to the Atmega 328P. Atmega 328P checks which animal has been identified, and SD card module will be storing the audio related to various animals. The SD card module will Atmega 328P requests audio from the SD card module with respect to the tailored animal. It receives the audio related to the tailored animal from the SD card module, and it gives the audio. Atmega 328P gives the audio signal to the palm amplifier, which will be amplifying the signal and gives it to the 10 watt speaker. After that, from the 10 watt speaker, it is played and deters the animal away. We have given a Wi-Fi router here so that it can act as the server for our entire system, to facilitate the communication between different Wi-Fi modules here. To powering up our entire system, we'll be buying a 12 volt power supply amp adapter, which will be converted to 5 volt and 3.3 volt, using an 7805 IC. We will be converting 12 volt to 5 volt, and using an LM317 variable regulator, we will be converting the 12 volt to 3.3 volt. 3.3 volt will be used by our ESP01 module, and 5 volt will be used by our rest of the entire system. Now this is our circuit design. So the circuits has been designed using these two DC EDA. So basically we have button here. This is for resetting our Atmega 328p when needed. We have in the H1 we have debug here because we all know that Atmega 328p is a DIP IC. Sometimes taking this out and putting it on an Arduino to program it can cause damage to the IC. As a result, we have made debug pins in such a way that we can program it and debug at the same time, using the 2, 3, and 4, 5 pins. We have given a crystal isolator for providing clock for our Atmega 328p. We have given power supply to the pins wherever it is needed. We have initialized 12 and 13 pins for Wi-Fi to connecting with the Wi-Fi ESP01, which will be connecting to the Atmega 328p using the software serial library. 19, 18, 17 pins and 17 and 10 will be used for connecting with the SD card module. SD card module at Atmega 328p communicates using Serial Peripheral Interface Protocol (SPI) protocol. After that, it sends and receives data using the SPI protocol. Ninth pin will be used for um, taking out the audio from the audio received from the SD card and giving the audio to the amplifier module. Now is pins from 23 to 28 are used for our LCD purpose, because for our LCD module we will be we will be using analog pins here because of the limitation of the data pin digital pins. Since analog pins can also be configured as digital pins, we can use these pins, it will work. So that's the overall design of the system. Now coming to the power supply part. So 7805 is a fixed voltage regulator which regulates the 12 volt to 5 volt. But LM317 is a variable regulator which can and which can be used to regulating voltage from 1.25 to 37 volt. So using the equation here, we have selected R1 and R2 value. As a result, inputting it to 12 volt, we will be getting a 3.3 volt output. This will be used by our ESP01 module. Now this is our power supply part. Coming to the power supply part, we know that coming to the power supply part, they have an LM317 317 here and a 7805. 7805 is a fixed regulator. There are capacitors here. Capacitors here are to avoid noises in the system. And well, we have used for LM317 circuit, we have used two resistors 330 ohm and 560 ohm to regulate given to appropriate pins in such a way that it can be the voltage 12 volt that is coming into it can be regulated, and it gives us a 3.3 volt output. We have also used it 100 mu of microfarad and 10 microfarad capacitors here for filtering out the noises coming inside the system. The same way we have used 10 mu of and 0 point mu of an our 7805 to filtering out the noises coming. Now this is our PCB layout. Using the diagram earlier, we have designed the PCB inside PCB layout inside the ECEDA. Now this is our PCB implementation on the copper clad. Now this is our product final concept. This is how this should be how our product will be looking in this final display. This shows our placement of component placement of our product. So we have a very big casing here which we will be combining our hardware parts, and we will also have a speaker to play the audio. Hardware and software used. Atmega 328p will be acting as the core of our system for implementing our logics. ESP01 will be providing will be used as a Wi-Fi shield for Atmega 328p for receiving data from the AI cloud. And then there is the ESP32 module will be used for testing purposes. LCD 16x2 will be used for uh, um, knowing the current status of our system. PAMA 8403 amplifier will be used for amplifying the sound coming from Atmega 320. SD card module is where our sound audio related to various animal is stored. 7805 voltage regulator is where we water regulator is used to regulate 12 volt to 5 volt. LM317 variable regulator is used to regulate 12 volt to 3.3 volt, and a 10 watt speaker is used to play the audio coming from the amplified audio coming from the Plan 8403 amplifier. Now the software platforms we have used. MATLAB will be used for hosting our AI model. ECEDA is a web-based EDA tool that enables hardware engineers to design and simulate our designs. We have designed it using our system using ECEDA. Arduino IDE for burning our code inside our Atmega 328P microcontroller. PyCharm for testing purposes of our system, sending and receiving data to the ESP01. Google Colab is where we have trained our AI model, which will be used inside the MATLAB. Since MATLAB supports .h5 files, we'll be training our AI model in Google Colab, then using it in MATLAB. Tinkercad is used for designing our casing. So this is our Gantt chart, our work plan. So coming to the result part, we have coming to the result. You can see the model accuracy versus epoch here. We have achieved a training accuracy of 98% and a validation accuracy of 73%, which is better for identification of it. You can fairly identify various examples has been showed here. The animal image has been streamed to a web server using a IP camera, and it has been snapshot of the boar. In the photo, a boar has snapshot of the boar has been captured by MATLAB program. Inside the MATLAB program, the AI model is identifies the animal, which is identified as a boar, as you can see here. The data of the identified animal is sent to the Atmega 328P using the ESP01 module, as you can see here. Now, after that, after the data is received, it plays the audio for animal. In the we have, as you can see here, is our final product and product implementation video here. Inside the product implementation video, we will be showing our product will be working. After the data is received in the Atmega 328P, it will be playing. It will be playing our audio. As here we have shown with an example of a boar playing the audio now.
So this is basically our Agroguard product. So we have two speakers here, and our casing is in the center, and we have initialized our module. As you can see, it is already turned on. Now we'll be looking at the AI. So basically this is the AI in MATLAB, which will be able to identify the animal. So I have provided the ESP01 IP address and my IP cam IP address here. This IP cam will be surveying the land area. For now I have used a software called IP webcam pro for purpose. After that, it will be the software will be taking images of the IP snapshots and providing it to the AI model, which will classify the images. Now let us start running the program. Start running the program. So this is our IP webcam. Okay. Now I am showing an image of the boar, and you can see that it has successfully identified it as a boar and playing a sound related to the boar. To chase away the boar, we will be using the sound of dogs to chase away boar. Successfully identified it.
From the video itself, we can see that after the identification has been done, the data is sent to the ESP01. From the ESP01, Atmega 328P checks the animal and finds it to be a boar. For chasing away the boar, we will be using a dog sound, and it was successfully able to play the dog sound after the identification of the animal as a boar. Now moving to the next part. This is our bill of materials. Now we have reached the conclusion. In conclusion, we were successful in creating an AI animal repellent, AI based animal repellent product Agroguard. The system is able to identify animals and play audio with respect to the animal. We believe that the development of an AI based animal repellent system Agroguard represents a significant advancement in protecting human lives and agriculture resources by building harmonious coexistence with wildlife. So these are our references used. These are our achievements. Thank you for listening to me. I hope this was a very good final year project, and I hope this was very much helpful to you. Thank you for listening to me. Thank you.